Today we're going to be taking notes about the atom. So we're going to be reviewing some of the information that you learned last year, and then we'll be adding some new information all the way. So make sure that you're paying careful attention. We'll start by reviewing the structure of an atom, and there are basically two major areas. We have the nucleus, this middle part, and then we have the space around the nucleus or outside of the nucleus. The nucleus is the tiny central core of the atom. Inside the nucleus, we have protons and we have neutrons. Protons are positively charged, and you will need to know this for the test, and neutrons have a neutral charge. Okay, so we have protons and neutrons inside the nucleus. Outside the nucleus, we have electrons. They are orbiting around the outside, and they have a negative charge, so they're represented here by negative signs or minus signs. Inside the nucleus, remember that our protons are positive, so they are the plus signs, and then our neutrons are neutral, so they just have an N to represent them. Going briefly back to the periodic table, the atomic number is going to be important to us because it tells us how many protons there are in the nucleus of an element. Generally, the number of protons and electrons are going to be equal, so that will also tell us the number of electrons orbiting the nucleus. Not always, so be careful. So just a review of the periodic table, again briefly, the element will be written, our atomic number will be the first thing, the symbol for the element will be written, and then the atomic mass. The atomic mass number is the total number of protons and neutrons in the nucleus. It's the mass of the inside of that nucleus. And remember that mass is the amount of matter, so the protons and neutrons that are there. For our purposes, if we have a decimal, we're going to round to the nearest whole number. That's definitely not something that you're going to do in chemistry later on, but for our purposes, that's how we will operate. Later this week, we're going to talk about how to make a Bohr diagram. And our Bohr diagrams are going to show the number of protons and neutrons within a nucleus. They're also going to be able to tell us how many electrons there are in an energy level. We're going to be working on that on Friday. So for right now, just know that Bohr diagrams are coming up. There are 7 different energy levels for electrons that atoms have. The row or period that an element is found, wherever it's found on the periodic table, that's going to tell us the number of energy levels where the electrons are going to be. Electrons in an atom aren't always the same distance away from the nucleus. Some are closer to the nucleus and some are further away. The electrons that are the farthest away are called valence or valence electrons. I like to compare this to kindergartners at recess. You remember that when you were younger and you were at recess, some kindergartners really like to stay close to the teacher, if we consider the teacher to be the nucleus. Others, they like to be further away. Some of them very far away. Some of them even tried to escape. We'll talk about that a little more when we talk about bonding. So if you think about electrons, they are moving around rapidly, much like kindergartners at recess, and the teacher is the nucleus. Some of the electrons like to stay close to the teacher. Some of the students like to stay close to the teacher, or the nucleus. And then some of them like to be further away. They're all at different levels. Our valence electrons are the ones that are involved in bonding. And chemical bonds can form when valence electrons move between two atoms. Electrons can either move from one atom to another, or sometimes they can be shared between the two atoms. Our energy levels are depicted on this slide, and you're going to have an electron configuration chart. And go ahead and write this down in case you lose your chart. But within the first level, you can have 2 electrons. Then that shell is full. So then you move on to the second level where you can have 8 electrons. And then you'll move to the third where there can be 18, and the fourth where there can be 32. There's even more shells than that, but you'll see this on your handout. Atoms that are in the same column or family have similar structures and characteristics. You know this from the periodic table notes. So for example, the atoms in the 18th column are in the same family, and they all have outer energy levels that are completely filled with electrons. We're going to talk about this more in class, so if you have any questions, make sure to write them down, and don't forget to include a summary.